Let me show you how I inspect a house. The first thing I do is walk around the exterior, and then we'll do the roof, and then we'll go inside and take a look at the big systems like the foundation, the heating, the cooling, the plumbing, electrical, and things like that. And then we'll move through the rest of the house and end up in the kitchen. So when I start a home inspection, I'm thinking of how does the exterior manage water? How does the roof catch all that water, collect it, manage it, control it, and then divert it away from the foundation? So what I'm going to do is I'm going to look around and inspect the grade around the house and imagine rainwater hitting that roof, being collected in the gutter, controlled and discharged down the downspout and out. And we want that water far away from the house. Building code helps my home inspection. Code says the surrounding area, the ground around the area of the house foundation should be sloped 6 inches in the first 10 feet. So let's walk around and see if we see that. I'm not a code inspector, I'm a home inspector, but code helps me do my inspection. You know, there's code inspectors, the township inspector, when things are being built and when things are being renovated, they come. And the bank has an inspector when you're financing a home being built. But no one else inspects a home that has been lived in for the life of the home, except for a home inspector, right? So we look at things with code in mind, but we're not really code inspectors. This looks great. This driveway is a hard surface and it's sloped away from the house. So are the front sidewalks and the steps and the stoops. Okay, so I've got a roof. I've got this downspout here, diverting water away. I've got this area here. It should be sloping away from the house. And it's not really. That front area there is kind of flat. So I want to look on the inside at the foundation to see if we have any water problems or moisture problems. And then this downspout is diverted into a pipe, an underground pipe. And there's only so many things I can see. Underground drainage pipes, can't really comment on them. This one here is discharging a lot of water here. We don't want that water to go towards the house. If it does, we'll have maybe water problems going into the house. That exposed area of the foundation is perfect for me because I want to see that clearance between the bottom of the siding and the walkway and the sidewalk and the front porch here, because I don't want the siding to come in contact with any kind of water or ground. So there's plenty of clearance here between the bottom of the siding and the gravel and stone here. If we keep walking around, we have a flat surface here, steps going up, flat surface, so maybe some ponding or puddling in that area. Want to make sure we don't have any water problems going in. I'll take a look at the deck. So this is the back of the house, the rear right corner. Looks like it's sloped away from the house. Looks like it's sloped away this way from the house. There's clearance between the bottom of the siding and the dirt. We don't want any of the siding to come in contact with the dirt. The fence is kind of old and beat up a little bit. And there's a lot of dense vegetation as well, shared with the neighbor. But this is my concern. So water can wick into masonry. And when this house was built, they did, looks like maybe a slight coating, a parging of cement, and then a bituminous material, a coating of like that black roofing tar. They roll it on. And that is damp proofing. That's what it's called, damp proofing. This isn't waterproof. This is just damp proofed. There's some vents in there, but they've been sealed up like an old crawl space vent. But I think we have a basement, so maybe it was originally a crawl space and then they lowered the floor. We'll take a look on the inside. But this is good. At least it's not the paint. I'm not concerned about the paint, but at least there's cement parging and some coating that I can see to prevent that water from going in. And then I'll take a look at the deck underneath to make sure it's sloped away and that the downspouts, well, I've got a downspout here, it goes underground. Maybe it discharges out there. And also I have a sump pump, it looks like. So that's a discharge pipe. And this looks like a discharge termination for that downspout. All right, so that's the exterior. The gutters look good. The downspouts look good. The drainage, the surface, the surrounding ground around the house. Got some underground pipes. Everything seems to be sloped away. A little bit concerned about the front, but we'll take a look on the inside. How this area is a little bit low there. Kind of just settles with water possibly during a heavy rainstorm. So we want to take a look at that, see if there are any water problems. And this downspout dumps a lot of water right there as well. Dense vegetation at the fence, and the fence is in okay shape. Then it's siding. We have good clearance between the bottom of the siding and the ground. Now the condition of the siding. I like to identify for my clients what type of siding it is. It's vinyl, and it's designed to divert and kick water away from the house. Again, that's why it's so important to control water. I'm always thinking about water management. Every home needs to manage water, control it and divert it away. And siding, where there are holes or gaps, like here, could allow water to enter. Now behind the siding materials, well, there's usually a drainage plane, but you can't really see it. Here's a concern here, where something is in contact with the siding. So wherever there's two planes or two components or two systems, something that intersects with the siding, I take a closer look because we don't want water to go into that area. It should be flashed and sealed. And this looks a little loose here where water could go underneath. Well, like that and go there. We don't want water to go here. So I don't think this was professionally installed. This roof was, but not this flashing intersection. This is the most important part. The siding is a little bit wavy because they didn't use a proper channel or a fitting, like a little ledger board or a control joint at the bottom to control this siding here. And we don't want water to go in here. So I want to see flashing where this siding comes down to the deck. And this is a ledger board here. We don't want an open gap to allow water to go into the house. So on the inside of the house, I'll take a look for wood rot. And here's a rail, a guard, and we don't want water to go in those openings right there. And at the top of the door. See, anything that goes through the siding, I want to make sure that there's flashing all around it. Top flashing, siding, side flashing, the surrounding flashing here, where the siding meets the deck. Every bit and piece, like imagine rainwater going there, and that there is all open, right? And that's a piece of wood at the windowsill. And over time that could rot. And that flashing there. All these are concerns that I'll take pictures of and put in my report. So the siding goes up to the top of the roof where the gutter is, and that's a soffit, eaves, and soffit vents. So we've got those little vents there. We don't want those to be blocked off. And it looks kind of inadequate. If there actually is a ventilation area, that needs to be opened up to allow air to go into the soffit area, into the space between the roof and the finished ceiling inside. Maybe there's an attic space, or maybe it's not finished. We'll take a look. But if there's ventilation, we need a lot of ventilation. There's a ridge vent at the top of the roof I can see, but it should match the amount of air ventilated down here. So if it's going to exhaust up there, a certain cubic feet per minute, it needs to exhaust, intake needs to go in, if it's going out, here. So we just have these little vents here, and that might not be adequate. Okay, so that's the exterior ground and the siding. Let's keep going. As I was walking around, I noticed that the deck floor is goes down a little bit. Like there's a dip there, bit of a settlement. I don't know if you can tell that way, but it settles there. So let's go underneath it and check it out. So I'm underneath the deck, and there's been a lot of repairs. So there's been a lot of new pieces installed, like that solid blocking above my head. That helps a couple things. One of them is to make the floor system a little bit more rigid so that the joists can span longer too. And this area here seems to puddle up with some water during a heavy rainstorm. There's a discharge pipe coming out, and it discharges there onto the ground. So there's a lot of, I think that's a second sump pump. Not sure, we'll take a look. And then there's a lot of water here being discharged from this downspout. So there's a lot of water under the deck, and these posts here are new. They've been installed under this main load-bearing beam above. So I want to take a look at that. Maybe that's the cause of the sag. So I'm underneath the deck, trying to figure out why there's a sag above my head, and I figured it out. When you're inspecting a floor system, you want to see how this floor joist or beam or component is being supported. On this side, there's a big beam, a doubled 2x8 on big 6x6 posts on concrete footings. That's really nice. Then it spans from that beam all the way over to this one, and this is a single 2x8 on a ledger board. Ledger board's okay, but there's posts here that hold up this span, and this is sagging. This beam here, we call it an end joist because the ends of the joists are attached to it. Rim joist, end joist, and that end joist connects all of the ends of the joists, and this one here is sagging. You can see it sagging by the eye, and it's probably because this beam here, this post here, column, is not supporting it very well. It has sagged, and I don't see, or I can't find any concrete footings on the bottom of these load-bearing posts, unlike what they did here. Big concrete footings, very good attachment to the footings, to the wooden 6x6 columns, and the doubled 2x8 beam. So that's supported well on this end. Some blocking here, that helps a little bit, but on this end, that's why there's a sag. And that's why this whole deck floor kind of goes down like that. Kind of goes down here. Underneath the deck, and I'm looking at how the deck is attached to the house. At the ledger board, it needs to be fastened securely to the house. So this is the ledger board. It's bolted to the house with these big lag screws and nails, but I don't really see flashing. It was installed on top of the old siding, the asbestos siding. So that's what's behind the current siding, the vinyl siding. I was just concerned about how this is attached to the house, and it looks adequately fastened, so that's good. Ideally, we want to see some flashing to divert water from this critical area, but everything seems to be good right now. And I'll take a look on the inside to make sure everything's okay. When I inspect the deck, one of the things I like to do is to make sure that the guard can support a push outwards. Not necessarily inwards, but outwards. Just imagine a bunch of friends pushing. It shouldn't go out. And also the spindles should be fastened securely, unlike this one, right? So that needs to be fixed. And then the space in between the spindles is more than 4 inches apart. That's large enough for a small child to fall through the guard. The guard is supposed to prevent you from falling off. But we know now that this house was built to code back then, but modern standards require the vertical spindles to have smaller spaces in between so that small kids don't fall out. That's a guard, prevents you from falling. At the steps is the handrail. It's supposed to be a graspable component of the stairway. This one is not graspable. You can't really grab it. And in a slip or a fall, a trip on the stairs, you want to be able to grab the handrail. So a handrail is different from a guard. This is a handrail on top of a stairway guard, side guard, step guard. It's supposed to be graspable, and it's not. The spindles are loose, and they're too far apart, a child safety issue. The floor decking is fairly in good shape. Just some normal wear and tear of the paint and stain. Some cracking could be difficult on bare feet. And also these fasteners, they could really catch you in your bare feet. And these cracked joists, floorboards, they could also be really difficult on bare feet. And then we have that structural concern about the joist sagging there. And then the other staircase, made out of masonry. The spindles are spaced closer than the deck. And that looks in good shape too. Except, is that graspable? No. So in an emergency, when you're falling and tripping, you want to grab onto something, you wouldn't be able to do it. Modern code requires that the drain waste vent pipes be inside the wall, the building cavity, so it doesn't get damaged or it doesn't have any problems with weathering straps like this one and that one above. So this is the concern here of this old type of installation. It's actually new material. It's PVC, but it's installed in an old way on the outside. Ideally, all the drains vent with one main roof stack. That one there should be the main roof stack. So for some reason, this pipe is not vented with that one. All exterior receptacles need to be GFCI protected. So that's this little device here that trips and you just reset it and turns electricity back on. Let's reset that. And it's ready to go. They have different kind of covers. They're in-use covers. This is a little loose here. There we go. That's better. Now it's watertight. The main service line is overhead, above the driveway. Adequate distance. There's a minimum distance between the bottom of the wire and the top surface of the driveway. And that's good. It's attached to the house. There are drip loops there. And then the conduit comes down. The concern is the conduit strapping. It's all corroded and it looks a little loose. This is the meter, and then the conduit goes inside and the electrical panel is inside. And this is the grounding wire. It has natural gas. That's the gas meter, gas shutoff valve, regulator, mass meter itself, and then it goes in. There's the air conditioner electric, the shutoff for the air conditioner line there. And then there's the EV, the electric vehicle plug. That's really nice. Love the homemade covers. This air conditioning unit is brand new. I'll take a picture of the label, the manufacturing label, to get the serial number, model number for my client. The refrigerant lines are sealed. The disconnect is behind it within sight. It's on a good stable base. It's running right now. It sounds like it's operating well. No noise, no rattling. We have 2 vent pipes here. That must be from a high efficiency gas furnace. We'll take a look on inside. Got some cable and utility. So that's in good shape there. All right, let's use the drone and perform a roof inspection. Let's go. So I'll take a look at the roof using my drone from the safety of the ground, never leaving the ground. And I want to look at the roof covering materials. That's all I can see. I can't really comment on all the components of the roof installation. Can't see the fastening, can't see the underlayment, for example. Can't really see the decking. But what I can see is that this roof is in good shape. It's a laminated shingle, asphalt shingle. There's that ridge vent on the roof. So I typically fly along each plane and along the ridge. There's the masonry chimney. We saw that from the attic space. The top of the masonry looks okay. A couple small cracks. There's an interior flue liner. Could put a rain cap on top, but that's okay. Now look at the masonry structure itself. And there's the edge of the roof. So I went along the ridge. There's a smaller roof porch there. Same material, same good condition. The gutters seem to be clean. I don't see any major damage, no hail damage, no cracking, no holes. There's that flashing there. A couple pieces of loose flashing. See how the step flashing wasn't really installed well on the sides. That's the black pieces of metal flashing. Those edges are open. So it's missing counter flashing. What's missing is counter flashing. So those pieces were just kind of fastened and glued in place, and that's not reliable. There are the vents. You saw these from the attic space. There's the main vent stack there, and I just want to make sure that there's no damage and the flashing is in good shape. I can also take a look at the gutter with my drone, make sure it's clean. The roof vents look good. And the fasteners on the flashing are sealed. So that looks like the kitchen vent, the main sewer line vent, and the bathroom vent. That's perfect. And I can see other components as well. Get a good picture of the deck, and a large overhead shot of the roof itself with the chimney, front porch roof, the gutters, the patio. So I feel like using a drone is a very good way to inspect a roof and all the other components of the house as well. And it's a very safe way to do it. That's the inspection of the roof using a drone. So now let's inspect the basement. And this is the access to the basement. An outdoor staircase, and you gotta watch your head, low ceilings. Thank you for the sign. If this was built to code today, that height in that staircase would be much higher, so we don't bump our heads. Okay, we're in the basement. And now I'm going to apply everything that I can remember that I saw on the outside to my inspection in the basement. And a lot of that has to do with water management. How did the exterior manage the water? Did it do well? Were the downspouts diverting far away from the house? In the front, there's a patio that's kind of level and flat. We want to make sure that there isn't any water coming into the basement through the block foundation wall. The block foundation wall we saw in one part of the foundation that was exposed was parged with cement and some black roofing tar. The bituminous material was painted on. That's good. To waterproof, well, waterproof isn't the right word. It's damp proof. If you have a high water table or a foundation that's being built in the ground that has a lot of water pressure, that needs to be waterproof. That's a different type of foundation drainage on the outside. What we typically see in most homes is damp proofing. Damp proofing. It's not guaranteed that the basement or the crawl space is going to stay dry. So we have to take a look, especially after every rainstorm, to look for watermarks to see if there are indications of water. And there's a little bit here. You see the staining, a little puddle of water here, and some staining there at the stairs. And I like to take a look at anything that can absorb water that's sitting on the basement floor, like wooden legs of tables and cardboard boxes and carpeting. And if those items are wet or showing signs of water, then we have indications of prior water. Another thing I like to look at are sump pumps. And I remember two drainage pipes, one underneath the crawl space, underneath the deck, and one in the corner at the rear right corner downspout. Here's that discharge pipe. I see that discharge pipe, and this is where it's coming from, a sump pump. We have a dehumidifier draining into the sump pump. It's a manual float. I'll turn that on. It's plugged into an extension cord, not good. It should not be an extension cord. Extension cords are really temporary use. Where's this going? Goes over here, goes over here, goes over here. I can't tell where it goes. I know it's an extension cord, and that's no good. Extension cords are for temporary use only. So whenever I'm looking in a basement and I see an extension cord being used for something like a light fixture, I guess that's okay. But this is being used for a sump pump, which is going to help you control the water intrusion problems. In the basement? No. This needs to be on a more reliable electric circuit, a dedicated circuit, 15 amp, 20 amp, GFCI protected, labeled properly wired, maybe with a battery backup. Okay, so there's that system. What about that other discharge pipe? Looks like it's that. So there's a discharge pipe going out underneath the deck. Here it is here. Oh, tubing. This reminds me of a sump pump or a condensate pump. That's what it is. So you kind of have to figure it out as you go. So there's the tube there, and there's the condensate pump. So the condensate pump is in the tray at the bottom of this HVAC unit. And this HVAC unit is one of my favorites. It's high efficiency, gas-fired, forced air. It pushes air through ductwork. So air comes from the house there, goes into the circulating fan, gets heated by the heat exchanger or cooled off by the air conditioner coil unit, and then gets pushed and distributed throughout the ductwork. And this ductwork is installed. This is not original of this very old home. It's been updated and wrapped with insulation. That's really nice. This type of heating system is high efficiency, and it has those two plastic exhaust pipes, which we saw outside. One was for fresh air intake and one is exhaust. And I actually labeled it for you. So the one on the left is for fresh air intake. That's for combustion. So to have combustion, you need air. So we pull air from outside, not from within the house. And we exhaust the fumes outside. This is so high efficient, it produces condensate. It's a plastic pipe. And all that's produced in here, a lot of what's produced in here is a lot of water. And that water, we drain it back to the unit. It drains down through the unit into a pump. And that condensate pump then discharges outside. And that is that tube. That's the discharge tube, and it goes through a solid PVC pipe, and it extends out underneath the deck. If there's a condensate leak problem, like when the air conditioner is running, or when the heating system is on and there's condensate draining from the flue pipe, there's a catch pan, and that catch pan has an alarm. If water starts to rise up in the catch pan, that alarm shuts off everything. And you're wondering, why is it so hot in here? Why is it so cold? Why isn't the system running? It may be that. This is a fantastic thing to have to keep our homes functioning well and healthy and safe. It's gas fired. There's the gas supply pipe and a drip sediment trap and a shut-off valve in case it needs to be serviced. And then looking for any type of rust or corrosion or damage to the unit. I don't see any. I think this is installed well. And it's relatively new. This is the air conditioner line. We saw the outdoor unit, the compressor unit operating. This is the refrigerant line, liquid line. This needs to be insulated. This one doesn't. But it produces condensate, and that condensate drains out of here. Here's a little safety switch in case there's a leak or a clog, and it drains down into the condensate pump, and that pumps outside through this tube that we saw. Here's the ductwork. Looks in good shape. This does not need to be insulated. It's the return. The furnace of the house is essentially the lungs of the house. And there needs to be an air filter. And the air filter, I bet, is under here somewhere. And that air filter needs to be changed frequently, or at least checked regularly. This is the fresh air intake. The pipes are supported well. You can see one is sloped, and those two go outside. This one produces condensate, and it drains back into, it's sealed here, because it's an exhaust pipe, essentially it's an exhaust pipe. We don't want any leaks. So I want to see all these fittings nice and tight, nothing loose, because it's producing carbon monoxide. That condensate drains down there again. Everything looks dry and functioning. Up here, we have a receptacle for the condensate pump, and it's GFCI protected. The electricity is controlled by a breaker in the breaker panel. Let's see if it's labeled. It says right here, furnace, dedicated 15 amp breaker. Great. So that's our inspection of the furnace. Really good. In the basement, I take a look for structural problems and water intrusion. Settlement cracks, cracking, signs of water. Those are the two things I look for. So what am I looking for here? This is a concrete block wall. It's made out of units. They're called CMUs, concrete masonry units. Masonry wicks water. It's a porous material. Concrete wicks water. Wood absorbs water. And when concrete absorbs water, it leaves indications. Sometimes it's water marks or efflorescence. And efflorescence is salt. Salt deposits left behind after this material, building material, absorbs water, wicks water, and by osmosis moves that calcium from the ground outside. The ground has salt in it. The building material itself has salt in it, and then it brings it through wherever it's wicking. It goes from wet to dry, and once it gets to the surface, it evaporates and leaves behind the salt. In very bad situations where there's an intense amount of water intrusion for a long period of time, you'll see efflorescence. It's that white, chalky, powdery stuff. And sometimes you'll see the masonry materials on the surface spall, crack, blow apart, literally blow off, because there's a lot of pressure inside this building material when there's water running through it because of osmosis. It's called osmosis, where there's a water source ground outside, rainy storm, or underground water that has salt in it, and by osmosis, it wicks up through the material. And it literally increases the pressure per square inch. And the PSI, pressure per square inch, goes from very little to a lot. Could be 3,000 PSI, which is greater than the strength of the concrete. That's why by wicking water, a concrete masonry building material can explode, literally explode, where the pressure inside the material at the surface, where there's been wicking and osmosis and building of salt deposits and efflorescence, that can be so great it destroys the material itself. That's why it's so important to manage water around a house, even with concrete block walls like this, because every building material, well, not every, but virtually every building material we use absorbs water, wicks up water and moisture. So look for water problems down in the basement, especially during a rainstorm, and look for cracking. We don't want large cracks with big open spaces. In an old house foundation like this, if I saw some cracks, okay. If this was a brand new house and we saw step cracks or shrinkage cracks or vertical or horizontal cracks, and there's displacement and movement in the wall, that would be a serious issue. In an older home, a very older home, this is 60, 80 years old, a couple cracks, that's just fine. What we don't want are cracks that indicate major structural settlement that has not been noticed for a long time, and a lot of water coming through. And I don't see that here in this basement. We have some repairs. We have a little post there. The columns, they seem to be vertical. The floor joists, they're original to the house. The span seems to be okay. I don't see any sagging joists. I don't see any major repairs of the joists. Looks like some joists have been sistered to repair the joists. Like this one here. This one was attached to this old joist here. Not sure why, but they used metal joist hangers. That makes me smile. This is really good. I love to see metal fastening, especially on older structures that have gone through some renovation or repair. So all of this looks good. I can't see through the insulation, right? But I'm gonna look as best I can. Let me show you some tools that I use in order to inspect in a house like this with insulation covering things. The one tool I like to use is obviously my high lumens flashlight, right? And I get to see things that I wouldn't normally be able to see without it, because that is completely dark without it, but now I can see stuff. So that's great. Now, what else do I use? Well, now that I can see stuff, what if I use this tool? This is a 3-tine hoe. It's a gardening tool, and it's on an extension arm, and I can use it to hit and knock, and also to move insulation if I wanted to. I can grab this insulation and move it a little bit. And I can also go around and hit and listen. It's extremely valuable, this sound. Listen to it. That's solid. If I hear something hollow, that's a different sound. No, that's good. That's good. All that's good. So this is a handy gardening tool that helps me inspect the structural components of a house. The other thing I like to use is when I'm with someone and I need to explain what I'm looking at, I'll use this. It's a laser beam. I don't want to shine it. See it? It's green. Don't shine it in anybody's eyes. So if I wanted to explain what I'm looking at, right? This is the condensate pump, right? And this is the tube that goes up. And it goes along there and discharges outside. And this is the cold air return. The air returns into the furnace here, circulated by the fan, gets heated up or cooled off, and then it's distributed with the ductwork. And that's the condensate pump. That's the pan there. And right there is the alarm. And right there is the exhaust pipe and the flue pipe coming in, the exhaust going out, and the furnace is there. And there's the gas supply line through a shutoff valve, and the gas line goes there, and this is the air. It gets circulated by a fan. So yeah, it comes in handy, this little laser light. During a home inspection, I inspect the laundry. I'm in the basement, and this is the laundry area. So let's check out the laundry. First thing I do is I run water, and we've got a tub here. So let's run hot and cold water and see where it drains. Well, it's draining into a P-trap. That's good. That P-trap is good. But it drains into like a sump pump, like a bucket. It has a float and a discharge. And it discharges, where does it go? It discharges through there, a check valve. That's what you know is the discharge pipe has the check valve. And it goes through a shutoff valve there in case it needs to be repaired. And then it goes up here and it discharges in this fitting, and it goes down in the public sewer. Perfect. It doesn't discharge outside. This is a vent. It's venting. There, it just discharged. But there's another vent, atmospheric vent, and it goes up here, it goes up there, and then it goes outside, and we saw it previously. It's venting up by the roof on the outside of the house, and it's not installed very well. The straps are rusting and falling apart. This is an old school way of venting. It's up to your township, your building inspector, whether that's permitted or not. They could have installed an air admittance valve or installed the piping for venting in some other way. So I'm not a code inspector, I'm not a plumbing inspector. I would just notify my client to ask some questions about the venting of this system that collects the drainage water of the laundry tub. And there it goes again. We want to vent outside. So that's hot water. That's cold water. No leaks. I'm looking for leaks. This is the stand pipe for the laundry, the clothes washer. So this stand pipe has to be a certain height. We don't want it to overflow or back up on us. So the hose goes in there. There's a trap there and a little bit of a distance between that trap and the weir. And this vent pipe, again, it's venting out. This is also discharging into that same pump. So we've got a tub draining into the pump, and we have a clothes washer draining into the pump. That's a lot of water. We have to make sure that this pump is in good shape, especially when we're using it. We don't want it to clog up and leak all over the floor. Possibly there could be a backup system or a catch pan with a warning system that something is going wrong here. The electricity, we don't want that to turn off either. It's plugged into a GFCI. Essentially, this is a laundry room. All receptacles in a laundry room have to be protected by a ground fault circuit interrupter, a GFCI. And that's what we have here. Any receptacle in the laundry room has to be a GFCI. Even the clothes washer. And there's the electric dryer. So that has to be GFCI. Everything here has to be protected by a ground fault. These are elevated to make it easy to access. I don't think it needed to be elevated for the discharge. I think it was just for easy access here. So there's that. You can step on that, maybe for a little kid to help out. Get the clothes washer emptied. And there's the dryer vent pipe. And that's in good shape. We don't want that to be damaged. And there's hot and cold water at the valves and stainless steel braided mesh hoses. GFCI at the receptacle. Hot and cold water. PEX supply lines, shut-off valves, and the tub's in good shape. So that was the laundry inspection. So we have public water coming to the house, and I found the shut-off valve, and it's labeled, so that's nice. This way with the handle turns off the water. This way is on. Got the bonding jumping wire here, part of the bonding of the electrical system. And then it turns from copper to PEX, this plastic pipe. That's PEX. And so for PEX, I want to take a look at the way that the fittings are installed. We don't want any water leaks. So cold water comes in and it goes to the water heating tank. This is a gas-fired unit. Gas line goes down through a shut-off valve, goes into the burner, gets heated up. Exhaust gases go up through this vent, and ideally we want the vent to go straight in there, sloped nice. We don't want it to go up and then down. So maybe we could find out how we could adjust this flue so it's venting properly. Should have a nice slope to it. I don't want to see any indications of backdrafting like carbon or rust and corrosion or excessive heating here. So you want those flue gases to go right up through here and into the chimney. This is an expansion tank. When water heats up, it expands and that absorbs that expansion. The bottom of the tank, I don't want to see any watermarks. I think that's old watermarks, or maybe watermarks from a pet. And here's the cold water coming in, hot water coming out. And then it changes from copper to PEX. And I just caught this. They have a nice filtering system. Looks like the date has been scratched off, but if you put a filter on a water line, it now has to be maintained and checked regularly. So that's the hot water tank. I think the flue pipe is the main concern. Outside we saw the electric meter. Here's the main electric panel board with the main disconnect. It's 200 amps. This is the main disconnect here. These are the other devices, breakers. What we don't want are any openings. There was an opening, missing breaker here, removed it, so they put a cap here, that's good. What we do want to see are the breakers specifically identified. And it looks pretty good. Not perfect, but it's identified well. The wires are modern cables. So they removed, I bet, the old knob and tube wiring or the old Romex and installed new Romex. There's 3 wires in this one, for example. There's a hot, neutral, and a ground. So I'm going to take a look at the receptacles throughout the house. I bet I'll see 3-prong receptacles. Everything looks good here. The wires are clamped and secured. The wiring has been updated. Breakers are identified. The main breaker is installed. There are no hazards that I see. Everything is on. Now, there are no ground fault breakers or AFCI breakers, arc fault circuit interrupter breakers. 2 different types of breakers that could be installed in your main electrical panel that are required by code, modern code now. So it's up to you as a homeowner to install or upgrade if you wanted to. Modern code requires a lot of rooms in your house to be protected by those 2 safety devices, GFCIs and AFCIs. So you may want to consider making that. I would, as a home inspector, would recommend my homeowner to consider upgrading these circuits with an electrician to AFCIs and confirming that wherever there's a hazardous location, a wet location that requires GFCI, those to be installed as well. GFCI, AFCI, and really good circuit design help homeowners ensure their homes are safe, functioning, and the circuit wiring is up to its capacity. So I inspected the water coming in. It got heated up by the hot water tank. Now I'm looking at the drain waste vent. Pipes, like from the shower above. Looking for support, good connections, glued, the proper direction, everything should be pointing this way, and everything should be sloped downwards as well. So we're moving along, picking up more pipes and fixtures and fittings, and it goes into the main sewer line with a clean out. And that goes out to the street, and that's a cast iron pipe. We could do a sewer scope right there. Just pop that cap, the clean out, and scope it from the house to the street out in front, which is about 50 feet. That would be a good idea. Otherwise, I'm looking for any kind of water leaks. I could use my eyes and I could use my hands. Sometimes that isn't all that fun if I find something that I don't want to touch. And also look below the pipes. So on the floor, if it's been leaking, there'll be watermarks along the pipe. There'll be watermarks along the pipe. And I don't see anything like that. And when there's insulation, sometimes the insulation will hide things like an old plumbing leak. So I'll just tug the insulation just a little bit to see if I feel anything or see anything. Nope. So that's good. Oh, there's an old junction box with old wiring in it, disconnected. That's just fine. So plumbing coming in is good. Drain going out is good. So we've been in the basement for about a half an hour or a little bit longer, and we've inspected a lot. We started with the outside load-bearing structural walls, the concrete masonry units, and we talked about water intrusion and damp proofing and difference between damp proofing and waterproofing. And we looked for watermarks, and we looked at the load-bearing components, the columns and the joists and the insulation and how we inspect them. We also looked at the furnace. The furnace is in great shape, new. It's the lungs of the house, so it needs to be regularly maintained. Every year, get your furnace and air conditioning checked. We saw the water coming in, the shutoff valve, distributed by copper pipe and PEX, modern water lines. It gets heated up by a relatively new hot water tank. And we also saw the drain lines, the white drain lines going down into the main sewer line, going out. And we saw the electrical. The electrical panel board is in good shape. The breakers are identified, 200 amps, that's a lot of capacity, and newer wiring. And we also inspected the laundry room right there. Our main concern is, I would say, the basement has had water issues in the past. I think that's why there's a sump pump, which is a great idea, but a battery backup system would be good, and it shouldn't be on a unreliable extension cord. And that's the inspection of the basement. I want to show you a cool tool that I have. It's called a hydro sensor, but what it is to me as a home inspector is I can see through the carpeting. So I use it, if this was a basement, let's say. It's not a basement, so I'm just using it here just to show you as a demonstration. If I was inspecting a lower floor, a first floor concrete on slab, a low floor basement with a finished floor material, and I wanted to see what's below the carpeting into the padding to see if it's wet, I would use this. So I just go around and I look for water, and it helps me do that by doing this. So it has these two prongs, and if I wet my finger here, it gives me a visual signal and an audible signal. I'm not measuring the moisture. I don't care. It's not a moisture probe. It's not a moisture meter. It's not quantifying anything. It's just telling me, hey, I found something wet. Maybe we should look at it. So it's kind of good for areas around a door and in ceilings where you can't reach. Now don't use it too hard because you'll put holes all over the place, right? So I just thought I'd share my cool tool I use. So I'm inspecting the attic, and this is the attic access. It's pull down stairs. Now, there's a weight limit to these things. I'm not the lightest person. So before you go up, just like the use of any ladder, it has to be absolutely safe. You don't want to fall. So one of the things I like to check are the connections at the hinges and the steps themselves. We don't want any loose parts. We want everything to be solid and connected really well. And as you go up, just go up slowly. And if you hear anything like creaking or falling apart, just don't go up. This is really handy, easy access to the attic, but it has to be absolutely safe. All right, I'm inspecting an attic in the summertime. It's maybe 120 degrees up here. So it's gonna be an efficient inspection. When I inspect an attic under the roof, I'm looking at structural components. I don't want any modifications. I don't want any rafters or trusses to be cut excessively. So all of these boards I'm going to look at as much as I can. I can't see everything, but I'm going to take a look at as much as I can. And the ridge board, I'm going to look up there. There's a ridge vent on the roof, and I can see daylight coming through that space. I'm going to look at the wiring while I'm up here. There's newer Gromicko wiring. That's good. The old knob and tube was taken away. These are rafter ties, and they're installed every other rafter bay in the upper third. That's perfect structural application for this. This holds a lot of things. There's a lot of structure going on here. You don't want to remove these in order to make more room for storage. And then the insulation. I'm going to take a look at the insulation as much as I can. I see some insulation has been moved and some insulation has been added, but it's thick in areas and thin under my feet. So it's only 6 inches under my feet, but a foot elsewhere. The flooring is nice, but you're losing insulation thickness. You want insulation to be as thick as possible. There's a whole house fan. We'll turn that. No, we won't. It has been disconnected. So the wiring there is disconnected. So this is open. This is essentially a hole in the ceiling envelope. And so we want to close this off. And if it's not going to be used, and it shouldn't because there's central air conditioning, we need to close that off. This is an energy loss. There's the kitchen exhaust that goes outside. There's the vent that goes from the bathroom outside, and there's the main draft. And this is the brick chimney, and that's being used by the hot water tank. I'm going to look for water problems or indications of roof leaks. And I'm going to look at the structure as well. I'm going to look at the insulation. And I can't predict any roof leaks, but I'm going to look for signs of roof leaks. This house is 60, 80 years old. I'm sure it has leaked in the past. I'm looking for signs of active roof leaks. It's hard to tell. But if my client has a roof leak, I want to be the first one they call because I want to help them question unnecessary recommendations from roofing contractors. So I'll take a look at anything that has gone wrong with the home in order to educate my client and make sure that they can make a smart decision about what to do next and what actually needs to be repaired. All right, so that's the attic inspection. The floor, lacking some insulation, it's good for storage, and then the whole house fan, that should be covered up. This is the pull down stairs to the attic access. It should be insulated. If it's not insulated, there's a lot of air flowing right up through there and a lot of energy being lost. So this is an energy loss area. This should be covered up with insulation, maybe a really nice lid or upside down box that could be sealed and protect this area from energy loss. I'm going to inspect the refrigerator to make sure everything is working. Refrigerators are essential appliances that preserve food safety through proper temperature control. Step one, I start with electrical safety. I want to check that the refrigerator is properly plugged into a grounded receptacle with a 3-prong plug. This is usually an inspection limitation, so I don't move large appliances like refrigerators during a home inspection. According to the 2024 International Residential Code, IRC, kitchen refrigerator receptacles now require GFCI protection, and this is a significant change from the previous codes. So I look for GFCI protection either at the receptacle or the circuit breaker inside the main electrical panel board. I do not recommend removing the GFCI protection even if nuisance tripping occurs, if the refrigerator just keeps tripping off. This is a code requirement to keep people safe. The refrigerator receptacle, it can be on a small appliance circuit or supplied by a dedicated 15 or 20 amp circuit. 4. Check for any signs of water leaks around the base or behind the unit, which could indicate water problems and also create an active electrical hazard. Test the door seal operation by opening and closing both refrigerator and freezer doors. They should operate smoothly and close well and evenly with the frame. You want to check that the door lights turn off and on when the door is open and closed. You can do this by pressing the door light switch. Examine the door gaskets. They should seal tightly with no gaps, tears, or twisted sections that could allow cold air to escape. Poor gasket seals reduce efficiency and can indicate needed maintenance. Inspect the interior for damage, rust, excessive ice that could indicate temperature-controlled problems. Check the adjustable shelves and drawers for proper operation. They should slide smoothly on their tracks. Check the temperature settings. A refrigerator should be at or below 40 degrees Fahrenheit, and the freezer should be at 0 degrees Fahrenheit. Look for excessive ice or frost buildup that might indicate the defrost system has problems. I would like to look at the condenser coils if they're accessible. They're on the back side of the refrigerator. Dirty coils reduce efficiency and force the compressor to work harder. You want to listen to the compressor operation. It should start and stop smoothly without any excessive noise or vibration that rattles. If equipped with water features, this one doesn't. You want to inspect the water supply line and the connections for leaks or damage. You want to use the water and ice dispensers if it's present, using normal operating controls. You want to look for signs of previous water damage around the base of the unit and on the floor. And if it has a water filter, you want to check the water filter indicators. Take a picture of the refrigerator's make and model and serial number. Remember, GFCI protection and the door gasket condition are all critical for both safety and food preservation. Modern refrigerators are complex appliances requiring proper installation and maintenance and regular checkups like this one. And that's my inspection of the refrigerator in the kitchen. Let's inspect the kitchen structural components to identify safety hazards and functionality issues. I'm going to check the floors, the ceilings, walls, windows, islands, cabinetry, and countertops in this kitchen. Number 1, I start with the kitchen floor. I check for loose tiles, if there are some, damaged flooring, uneven surfaces, soft spots that could indicate water damage or structural issues. If it's tiles, I'll knock on the floor gently. Loose tiles will sound hollow compared to properly adhered ones. Then I'll look for proper transitions between different flooring materials. I examine the ceiling for water stains, cracks, sagging, or damaged materials that might indicate plumbing leaks above or structural problems. I'll check the walls for cracks, water damage, or areas where tile or paint are failing, especially around the sinks and appliances where moisture is common. Number 4, I'll check the kitchen windows for proper operation. They should open and close smoothly with functioning locks and functioning hardware. I'll check for damaged glass, broken seals in double pane units, or deteriorated weather stripping. Number 5, I'll inspect the cabinetry by opening and closing the cabinets. Just a representative number of doors and drawers. I don't need to test every single one, but sample enough to identify any patterns of problems. I'll look for loose hinges, damaged door fronts, drawers that don't slide properly, or shelves that are sagging or damaged. Cabinet doors should align properly and close securely. I'll open multiple drawers and doors simultaneously, especially in the corners, to check to see if things bump into each other. When inspecting kitchen cabinets, we want the wall-mounted upper cabinets securely fastened to the wall studs in the wall using appropriate mounting hardware through the cabinet's hanging rail, the mounting strip, or the manufacturer's proprietary hanging system. We want the cabinets fastened into solid wood framing with no drywall screws. We want to check that visible mounting screws look properly sized, installed flush mounted without being overdriven that could strip the wood or compromise the connection strength. I want to check the cabinet stability by gently pulling forward on the face frames. Properly mounted cabinets should show no movement whatsoever, no separation from the wall surface. And properly secured cabinets pose serious injury risks from potential collapse. Kitchen islands and countertops must be securely attached and not move when pressure is applied, like by a home inspector. To check the stability, I gently push against the island or the countertop. It should be firmly anchored to the floor and the structure, and it shouldn't wobble or shift around. I check the seams and joints for proper sealing, especially around sinks where water damage commonly occurs. I look for burn marks, stains, or other damage that affects functionality. I look at the countertop backsplashes for proper sealing against the walls to protect the wall from splashes, spills, and stains. Loose kitchen islands and loose upper cabinets are safety hazards. These structural elements affect the entire kitchen's functionality and safety. And that's my inspection of the kitchen structural components. I'm going to inspect GFCI protection, that's ground fault circuit interrupter protection, and AFCI, arc fault circuit interrupter protection, for kitchen appliances based upon the 2024 International Residential Code, IRC. Kitchen appliance electrical safety is critical for preventing fires, electrocution, and code violations. So let's inspect the kitchen. Kitchen electrical systems start with proper circuit design. First, small appliance receptacles must be supplied by at least two 20-amp branch circuits as required by the 2024 International Residential Code, IRC. These circuits serve all receptacles in the kitchen, pantry, dining room, and similar areas. Number two, both countertop receptacles and low receptacles, typically 12 to 18 inches above the floor, are served by these small appliance circuits. This means all the receptacles where you plug in toasters, coffee makers, and other kitchen appliances get their power from these special heavy-duty circuits. 3, a refrigerator can be included on a small appliance circuit or supplied by a separate 15 or 20 amp individual branch circuit. In other words, your fridge can share power with the other kitchen outlets, but it's usually on its own dedicated electrical circuit. 4, dining room receptacles controlled by wall switches for lighting are served by general purpose lighting circuits, not small appliance circuits. Think of it in this way. Outlets that control lights use regular house wiring, while outlets for kitchen appliances need the stronger circuits. And this circuit design ensures adequate capacity for kitchen electrical loads. The 2024 IRC significantly expanded the GFCI requirement for kitchens. According to the 2024 IRC, section E3902, that's all 125 volt through 250 volt receptacles serving kitchens must have GFCI protection. Not just countertops anymore. This means every kitchen receptacle needs GFCI protection. Number 6, code requires GFCI protection for specific appliances. including drinking water coolers and bottle fill stations, dishwashers, electric ranges, wall-mounted ovens, counter-mounted cooking units, and microwave ovens. GFCI protection is required whether the appliances are hardwired or cord and plug connected. Now, a food waste disposer that has a cord plugged into a receptacle within 6 feet of the sink, which is commonly installed underneath the kitchen sink, it must have GFCI protection. The disposer itself is not listed in the code here specifically as an appliance requiring GFCI protection, but it can be interpreted as such if it's connected to a receptacle in the kitchen. Number 8, GFCI protection is required for all receptacles within 6 feet of sinks, kitchen countertop receptacles, and 250-volt receptacles for electric ranges. 2-pole GFCI circuit breakers are required for 240, 250 volt loads. Test all GFCI outlets using the test and reset buttons. If they don't trip and reset again, they're defective and must be replaced. Kitchen circuits serving microwaves, small appliances, and plug-connected ranges all fall under this GFCI requirement. Understanding how the code evolved helps explain what you'll find in the home. Originally, only kitchen countertop receptacles near sinks required GFCI protection. Then, all countertop receptacles were included. And as of the 2024 code cycle, any kitchen receptacle requires GFCI protection. The 2024 IRC lists specific appliance requirements to eliminate interpretation confusions and issues. That's dishwashers, ranges, ovens, cooktops, and microwaves. They all need GFCI protection regardless of installation method. For dishwashers, GFCI applies whether it's hardwired or cord and plug connected. Single receptacles are preferred over duplex receptacles in cabinets to discourage misuse. Pay special attention to small appliance circuit design. Older homes may not have the required two 20 amp circuits. And we could check that the refrigerator circuit is properly designed as either part of the small appliance circuit or as a separate individual circuit. The code standardizes voltages at 125, 250, even though localities may have different service voltages. And that can be seen at the main electric panel board. Remember, you could use a GFCI tester to verify proper wiring and function, and you could check the panel board, the labeling, to identify small appliance circuits. Number 19, any appliances that are on extension cords or temporary wiring are major defects. All kitchen appliances need permanent electrical connections with proper circuit capacity, including GFCI and AFCI protection. The building code recognizes that dangerous electrical arcs can occur in any living space, making AFCI protection essential for fire prevention throughout the home. AFCI protection prevents electrical fires caused by arcing faults. According to the 2024 International Residential Code, branch circuits supplying 120 volt single phase, 10, 15, and 20 amp outlets in the kitchen require AFCI protection, along with family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, recreation rooms, it's not that over, closets, hallways, laundry areas, and similar rooms. Just about all 120 volt kitchen circuits need AFCI protection, including the required small appliance circuits. So check the main electrical panel board for combination type AFCI breakers or AFCI receptacles at the first outlet. The 2024 International Residential Code establishes comprehensive electrical requirements for kitchens: proper small appliance wiring, GFCI protection, and AFCI protection. And these requirements work together to prevent fires, electrocution, and ensure that the wiring in the kitchen can handle the appliances. Correct electrical wiring combined with modern safety protection devices saves lives and prevents property damage. Home inspectors, know about modern code requirements for the kitchen. And it doesn't matter how old your kitchen is. It should be inspected to make sure things are working and safe. We want to inspect our homes to make sure they're safe, functioning, and healthy. And that's my inspection of GFCI and AFCI safety protection in the kitchen.